So the viral particle, we call it a virion. The viral particle attaches to the host cell. When it attaches to that cell, it injects its own genetic information, whether it's DNA or RNA, doesn't matter, but that gets injected into the cell. And that genetic information then takes over the machinery of the cell, and instead of the cell making more of its own DNA, now the cell is making viral DNA. Right? Or instead of the cell making more RNA, it's now making viral RNA. Okay. So viruses contain DNA and RNA, and they contain almost nothing else. They reach a cell that they can interact with, they inject their genetic information into the cell, and then they force the cell to create more copies of it. So that is how the virus replicates.
Mr. Fox?
Yes?
So is it a single cell or no? Because on there it says that it's a single cell. So can
Right.
I yes or no? Just for the exam, because
So it does say single cell, but technically viruses are not even cells. They do not contain everything a cell would have.
so there's just
So-
particle or
So I would not call a virus a cell.
Parasitic particle would probably be better, right?
So a parasitic particle is a great way to describe a virus.
Parasitic particle. It's essentially just floating DNA that says, "Hey, what's good?"
Basically, right? It's just floating DNA inside a protein shell that just goes up and says, hey, what's good? Right? And the cell responds is like, all right, now, give me your wallet. Right? Don't want to interact with it, right? Don't want to interact with it. So, right? Just to recap, viral particle is a virion, and it causes the host cell to create more viruses. Yes, Emily.
So if the virion has DNA, that it's gonna inject the DNA and make more of its DNA,
Correct.
so it's gonna take over whatever it is that's injected.
Correct.
Okay.
And then if it has RNA, stick the RNA into the cell and force the cell to make more RNA.
Is that why viruses are like arguably more dangerous than like bacteria and whatnot, because they get stronger with each host?
So I'm not going to say that they're more dangerous. I'm not going to say that they get stronger or weaker. But just the way they do things is different. And so the way we need to handle them is different.
Okay.
Let's see. If I was to, right, so since we're on, so since we like to use analogies here, let's see if we can think of an analogy for a virus. How could we describe a virus? Well, basically it's like if I walked into a Denny's, right? And then I kicked out all the cooks and I started making Chinese food. Right? Because the Denny's are not supposed to make Chinese food, is it? Unless it's a Chinese Denny's, in which case all bets are off. Right? But if it's an American Denny's, right, and I just walk in, right, kick them all out, and I start making Chinese food with their kitchen, right? So I'm that virion, right? I inject myself into the cell, into the Denny's, and then I take over their stuff, and I start making more of myself. Or, you know, if I'm Chinese food, then I'm making more Chinese food, right? I don't know. It makes sense in my head, right? But the idea is the cell is no longer doing what it's supposed to do. It's just helping out the virus instead, right? The virus has hijacked the cell. Okay. Viruses may lie dormant for extended periods of time and then manifest in illness. Okay, so viruses can just be hanging out, not doing anything, and all of a sudden, something triggers them to become active. Viruses are not affected by antibiotics. This is very important. Remember, antibiotics are for bacteria. Antibiotics do nothing against viruses. So, if you have strep throat, which we said was a bacterial infection, right? You can take antibiotics for strep throat. But if you have the cold, or you have a flu, which are viral infections, you cannot take antibiotics to get rid of the flu, right? Antibiotics will not work. We'll discuss that. So, for example, when we had COVID, right, coronavirus, if anyone told you to take antibiotics for coronavirus, they had no idea what they were talking about, because antibiotics do not work against viruses. Right? Antibiotics do not work against viruses. Viruses are not bacteria. Right? Bacteria are an actual whole cell with all the organelles and all the mechanisms that are included in the cell. Right? Viruses, like Jay so simply put it, is just a piece of DNA, right, wrapped up in a protein that goes around and says, hey, looks good. Okay? So, what are some common viruses that you know about? Right? We've discussed COVID, we've discussed flu, but what other viruses? That's it? You know? Chickenpox, yes, chickenpox. Pneumonia, yes, we do have viral pneumonia as well as bacterial pneumonia. Yes, that's right. We do have a vaccine for chickenpox.
So does that not?
So a vaccine is not antibiotics. That's the key thing here, right? Vaccines and antibiotics are very different. TB, tuberculosis is a bacteria.
Polio?
Polio virus, yes.
Measles.
Measles is a good one.
Monkeypox, yes. So everything in that pox family, right? Smallpox, cowpox, chickenpox, monkeypox. Those are all viruses. Swine flu, yes, virus.
What about Ebola?
Ebola.
Virus.
I think it's a virus.
I
Ebola
believe
virus.
Ebola is a virus. That's the Marburg virus.
Mad cow disease was what again?
Mad cow disease is prions. Those are
That's a
proteins.
protozoa? Or
They're proteins, polyfolded proteins.
okay.
Alright, so very good. Looks like we do know quite a few viruses. So,
Influenza?
very common one, yep, influenza, the flu. Right, so as part of working in healthcare, every year we are required to get the flu vaccine to help give us protection against the flu virus. So, viruses can cause all sorts of issues. Right? Viruses can cause meningitis, right? Inflammation of the brain. Viruses are responsible for the common cold. Viruses can cause eye infections. They can cause pneumonia. They can cause muscle swelling. They can cause hepatitis, right? Hepatitis A, B, C. Those are viral infections. Right? STDs. Quite a few STDs are viruses. For example, HIV. Right? HIV is a virus. Right.
Yeah,
HIV is a
someone
virus.
said that earlier. I thought you said that that was a bacteria instead.
No,
Or-
I.
Somebody on that side just said that like 2 minutes ago.
Okay.
Like it
I
was.
said bacteria to something else. What was it?
Oh, okay.
I think TB.
Oh,
TB,
tuberculosis.
Yeah, sorry, TB.
No, you good.
So would
That's on me.
like chlamydia, would that be a bacteria or?
Chlamydia, that I do not remember. I have to look it up.
You can take medicine for that.
So if there's if there's
Like penicillin?
an antibiotic for it, then it is bacteria.
You can see, you can
Yeah.
get rid of that.
Alright, but what can we do to help fight viral infections, right? No, it's not like a computer. You don't have an antivirus program, right? Especially if you download a pirated antivirus program and it's the actual virus.
Landmark.
Malware. Okay, but against viruses, our main line of defense is the vaccine. So, big difference between antibiotics and vaccines. Antibiotics, you take them after infection. You get infected with the bacteria, you take the antibiotic helps to shut down that bacteria. But vaccines are not like antibiotics. Vaccines are best taken far before the infection. Right? Vaccines are meant to prevent you from acquiring the virus in the first place. Or if you do acquire the virus, it's meant to help reduce the severity of the illness. Right? So vaccines either help prevent or reduce the severity of the illness, and they need to happen before infection. Why? Because vaccines are like a training program for the virus or for your body. Vaccines help to train your immune system to respond to an event. Okay, so vaccines are like fire drills, right? You do fire drills ahead of time so that when the time comes, everyone knows what you're supposed to do to minimize the effects of the fire, whether it's putting it out or whether it's evacuating. Right? So vaccines need to happen first. There's no point putting a fire drill in the middle of a fire, right? At that point, it's too late to have a fire drill. You should have done this 6 months ago, right? Antibiotics are going to be like your fire extinguishers, they're your fire hoses, right? When the fire happens, that's when you use them. There's no point spraying the fire extinguisher if there's no fire around, right? There's no point taking the antibiotic if there's no bacterial infection. But once the infection happens, that's when the antibiotic should be taken. That's when you take out the fire extinguishers, that's when you take out the fire hoses, that's when you spray down the fire to put it out. Right? So antibiotics and vaccines, very different. Right? So vaccines, you take them ahead of time and they help prevent or they help reduce the viral infection down the road. Okay? Antibiotics, you take them when that bacteria actually infects your system.
Those are good
So,
analogies.
good analogies. All right, great, thank you.
So, like, my mom got the COVID vaccine,
Mhm.
and then she got sick, and she was like really sick for 3 weeks.
Mhm.
So does that mean she would have been worse if she didn't get the vaccine?
So, did she get sick immediately after taking the vaccine?
No, she got the vaccine, and then like a year later, she got COVID.
Right, so, in science I can't ever say anything with guarantees, but most likely the vaccine did help reduce the severity. Right? Now, keep in mind that as well, vaccines are tailored to the specific virus, right? Because the way your body responds to the viruses is they need to be able to recognize that virus. So what you do in the vaccine is you've got a bunch of dead virus particles that can cause infection, but it lets the body know that, hey, this is a bad thing. If you ever see this floating around, go on alert, right? So you get that vaccine, and then a lot of times people say after the vaccine, I felt bad, right? I maybe got a fever, I got chills. It was almost like I was feeling sick from the vaccine. Yes, that is what's supposed to happen. Your body is basically going through a trial run of what it should be doing anytime it encounters those viral particles. Right? So the next time it runs into that virus, it sees that particle, it's like, all right, this is a virus, I know what to do now. So if you do get infected with a virus with that particle, the body knows what to do. The problem is with coronavirus, with the flu, these viruses like to change up their particles very often. So one year's flu might have particle A, but next year's flu might have particle B. And if the flu with particle B shows up, well, the body doesn't know what to do because it's never seen it before. It's only seen particle A in the vaccine, right? So that's why we need to get vaccinated constantly, right? We need to keep our vaccines up to date, because if the virus does end up changing its particles, then we need to be vaccinated to train our body to recognize all those new particles.
Is that why they have those booster shots?
Right, so the booster shots to kind of help remind the body what it's looking for. Annual flu shots, because we are trying to predict what kind of particles the next year's flu is going to have and get our bodies ready for that ahead of time. Things like that.
So the vaccine basically changes every time it's being modified.
So depending on the virus, vaccines may change every year. On the other hand, sometimes you have something like tetanus, right? The tetanus vaccine doesn't really change that often. You can keep your tetanus immunity for like 10 years or something like that. Because that virus is not constantly changing out particles. So when your body notices it, then your body can still react to it 5-10 years down the line.
That's like the Tdap shot that we had.
Right, like the Tdap. Yes, Jay.
Brain fart. Never mind. Okay.
Alright, so great. Are we okay with the difference between bacteria and viruses? Are we okay with the difference in how we can treat them?
Yes.
Alright, great. So in that case,